Here is a demo of our coding interview solution. So we have given voice agent access to editor and it can conduct coding interview. This is how it works.
Hello there, welcome to the coding interview. I'll be guiding you through a problem-solving exercise today. I hope you're having a great Thursday. Did you know that a day on Venus is longer than a year on Venus? Before we dive in, let me quickly explain how this will work. You'll see a split screen with the problem statement on the left and an editor on the right, where you'll write your solution. Are you comfortable with this setup and ready to proceed?
That sounds good. Yeah, let's do.
Great. I will now reveal the problem statement. Please take a moment to read it carefully and let me know when you're ready to discuss your approach.
Yes,
Okay,
I got the problem.
The statement is now visible in the question tab.
Yes,
Please take your time.
I can see the problem. So the problem here is that there are two numbers and there is an array of numbers, and we have to figure out whether any of the pair here and the sum of which is a target. So let me take a few examples here, and if it's true, if we find that, then it's true, otherwise we will have to return false. So in this case 9 is the target number and 2 plus 7 9, so we got in the first attempt and it's true. In the case of the second one, 3 plus 2 we did not find, 2 plus 4 6 we found, so it's a true. So again we move on. And in third example, you have given 3 plus 3 6, 3 plus 5 8, 5 plus 3 8, so we did not find any pair, so then it's false, right?
Okay, you've clearly understood the problem. Now, can you share your initial thoughts on how you might approach solving this? What would be the first algorithm that comes to your mind?
I mean, the first algorithm is the way I was explaining, reading the problem in a way that I can go through every possible pair, which will be NC2 combination, and try to just match whether they add up to this particular number, which is a target or not. If they do, then we just return true. And in that case, we are doing n into n minus 1 by 2 sort of permutations. So order of n squared complexity in that case, right?
Okay, that's a good start. You're describing a brute force approach with nested loops, which indeed has a time complexity of O(n) squared. While correct, it might not be the most efficient, especially for larger data sets. Can you think of any way to optimize this to a better time complexity, perhaps by pre-processing or using a different data structure?
Yeah. So I think the other way could be that as I go through the number, like 2 plus 7, I know that I have seen this number and what number I need. So instead of calculating every number, as I go through the number, I can keep in a data structure what number I need, and as soon as I find that number, I can just do an early early return. So for example, in the first case, I just do like 2 plus 7 9. So at the 2, I calculate that I needed 7, and as soon as I reach 7, I can just return early return true in that case. So in the worst case, of course, I will have to go through each number, but in some cases I could just be more efficient. But in any case, worst case complexity would be O(n) in that case.
Okay, that's a significant improvement in your approach. You're on the right track, thinking about using a data structure to store the numbers and look for complements efficiently. To make it even faster, what data structure would be the ideal choice for storing numbers and quickly checking if their complements exist? What data structure gives you O(n) lookups?
Yeah, so my go-to option here was like matrix, perhaps, that we could have array, but in that case, it's not O(n) lookup.
You're close. Right, an array doesn't give you O(n) lookups. Think about a data structure that's designed for fast lookups using keys. What comes to mind now?
So one, I think set could be that we just keep adding to the set and we check that that particular key exists or not. So that could give us order of 1 lookup, and then for each number we go through. So that way we are storing, so that way we are going through each one n items, and for each items we are doing order of 1 lookup, so order of n complexity.
Excellent. A set is the perfect choice here, due to its O(n) average time complexity for lookups. You've clearly outlined the logic of using a set to improve the time complexity from O(n) squared to O(n). Now, before we start coding, could you briefly outline the steps you would take to solve the problem using the set approach?
Yeah, so let me write a pseudocode here. So we will in some way do keep a memory that what number we need, and this would be a set, and then we will go through each number, like for x in this nums array, and what we want to have is a complement which will be target minus x. And now I don't exactly remember how do we need to add and set, but here basically we will do two things, that if the complement in the memory already, so then we can just return true. Otherwise we just add to the set. So for now I will just make a comment here that add to set,
Yes.
and if
Okay, this pseudocode. Yes?
otherwise I will pass false. Okay.
That's a solid pseudocode. It correctly outlines the use of a set to achieve the desired ON time complexity. Now, are you ready to translate this pseudocode into actual Python code in the Solution tab?
Yeah, so let me do that. So first is I have to define a set, which I think this works. And for x and nums, we are calculating complement is target minus x. And if
Perfect.
complement in the memory, which is good, then we return true. I think Python true is like this. So this will be like here false, and we'll have to remove false. And I have to figure out how to add data in the set. I don't exactly recall how to do that. Is it set dot add?
Correct. You
Oh.
can use set add element to add the numbers to the set.
Okay, so then I can do a complement here. So does that sound good, this approach?
Yes, your code accurately implements the logic we discussed. You're efficiently using a set for fast lookups to achieve ON time complexity. Now, before we call it a day, let's give the solution a run. It seems there was an issue. The code editor did not save the code. Could you please write down your code again?
Yeah, I just did. Can you check again?
It seems like the code editor is still not saving the changes. This is an unusual issue, and I apologize for that. Unfortunately, we are out of time for this session, but I can say that your approach and pseudocode were spot on, and you correctly identified the use of sets for efficient lookups. Do you have any final questions for me?
No, this sounds good. Thank you so much. Yeah, so after the call, it will directly cut the conversation when it finds its end. We did have some glitch, like it was not able to read the code once, which we'll figure out. But this is a demo. If you are interested in trying it out, let us know. I can add you to our alpha test. Thank you so much.